Okay, number 12 is by far the longest problem in here. It really has 3 steps, okay? Step 1 is going to be to find the length of the side of the triangle. Then once you have that side, you can actually find the area of that triangle. And then since we know that the 2 areas are equal, we'll actually work Theorem 8-4 backwards in order to find the missing side. Okay, now I'm going to use the numbers that they give you in this problem just because it is so hard. So I'm going to walk you through the whole problem, so you'll end up with the correct answer right here. But just in case this happens to be on a quiz or a test later, you can go through and work again step by step this problem because it is quite lengthy. Okay, the only information they give us is that the area of the hexagon and the triangle are equal, okay, and that the triangle has a perimeter of 36, okay? Now, if its perimeter is 36, that means we added up the 3 sides and got 36. So all we do is take that 36 and divide it by the 3 sides to learn that each side measures 12 inches, okay? Now that we know that each side measures 12 inches, we can actually find the area, right? Once we have the side, we know that we can find area by that formula, square root 3/4 times side squared, okay? 12 squared is 144. So we have 144 square root 3/4. If we divide 4 into 144, we get 36 square root 3. Okay, so our area of the triangle measures 36 square root 3. Okay, now our goal in this case is to find the side of the hexagon. Okay, so it is not to find the area like we've been doing. So we actually now have to take this area and use it to work backwards. What I mean by that is usually for this theorem we write area equals half times apothem times perimeter. Okay? But the only thing we know right now is area. Okay? So we're actually going to insert then 36 square root 3 where it says area. Okay? Then we'll know that we're working out the rest of it. I'm going to need some more paper in just a second. But we're working out the rest of it here so that we can find the side. What's going to give us the side out of this is the perimeter, right? If we find the perimeter and we know that all the sides are equal, we can do just like we did in step 1 in order to find each side. I'm actually going to pause this real quick, grab another sheet of paper. Okay, we know then that we're going to work backwards from here so that we can eventually find our side. So what I want to do, I'm going to bring this up. Okay, we want to draw the picture of our hexagon. Okay, and same thing, so we know we can create equilateral triangles here. We know that we'll have an apothem right here that creates a 90-degree angle. And we know that we'll have a radius right here. We know that our radius and our sides are the same. Remember, the radius and the side in a regular hexagon are equal, okay? Now, this is where it gets confusing. We don't have any numbers, okay? All we're going to do is end up using a whole bunch of letters, which looks scary, but the concepts are still exactly the same as what we've been working, okay? So, if you'll recall, this cut this side into 2 equal halves, right? So, that means that this right here is half of the entire side. Well, since I know that the radius and the sides are the same, I can actually, instead of calling this half the side, I can call it half of the radius. How does that help me? Okay, well, if I form my 30, 60, 90 triangles again, okay, and I end up doing my proportions. So let's say 2 corresponds to, let's go left to right, R corresponds to 2. Okay, and then this half R corresponds to 1. You'll see this ends up giving you a true statement. R times 1 is R. Half of 2 is 1. 1 times R is R. Okay, so I know it seems crazy that we're using half R, as this is half the side and half the radius, but the radius and the sides are the same. But we're actually going to use it because you'll recall in our formula, half apothem times perimeter, we need the apothem, right? Okay, so let's use this proportion, R over 2, to figure out what our A is. A corresponds to square root 3. Oops. Hello. Okay, so square root 3 times R equals 2A. Again, we're solving for A, so divide both sides by 2. A equals the square root of 3R over 2. Doesn't look like I've solved for much, okay? But I'm given the apothem in my formula. Half times apothem, I can now actually enter square root 3R over 2. The last thing says times perimeter. Here's where it gets a little bit even trickier, okay? Our perimeter is all the sides added together. Well, I currently don't have a name for a side, do I? I know that I can call them S, because that stands for side. So I could say, well, side plus side plus side plus side plus side plus side. Well, there's 6 of them, so that would be 6 sides is my perimeter, right? But if I drop right down in here to this and end up putting 6S, I now have an equation that has an R and an S. That's a problem. So, since I know that R's and S's are the same, I'm actually going to call my perimeter 6R. So right here, I'm going to insert 6R. Now, if you'll recall, since we're working this backwards, we actually do have a number to go right here. That was the step 2, where we found the area is 36 square root 3. So what we're going to end up doing is working this backwards to solve for this R. I'm going to go ahead and put this over 1, okay? Why are we solving for R? Because R is the same as S. And what's our entire goal? S stands for side. Find the side of a hexagon, okay? So now we just finished working this out. I'm going to go across the tops over here first. So 1 times square root 3R is simply square root 3R. Square root 3R times 6R is, that's 6 square root 3. And R times R, remember, is R squared. Over 2 times 2 is 4. 4 times 1 is 4. Okay, R's in top, so what I need to do first is get rid of this bottom. How do I undo dividing? Well, you multiply both sides by 4. So that'll cause this right here to cancel. So I'm left with, that's 144 square root 3 equals 6 square root 3 R squared. Ooh. Okay, how do we get 6 square root 3 off R? Divide both sides by 6 square root 3. That cancels. Okay, in this case, square root 3's cancel out. 144 divided by 6 is 24. So So I have 24 equals r squared. And how do you undo a square? If you'll remember, we square root. Of course, we actually square root numbers that don't have perfect squares by factor trees. So you pick any two numbers. I'm going to do 6 times 4. That gives me, 2 times 3, 2 times 2. Okay, so I have a pair of 2's. Remember, we pull those pairs out. Oh, paper's moving again. Okay. So we pull that pair of 2's out, and we're left on the inside. 2 times 3 is square root 6. Oh, sorry. I'll pull the camera out in just a second, okay? So that says equals there we go. Equals r. So the radius equals 2 square root 6. Once again, we have to go back to the knowledge that the radius equals the side. So if the radius is 2 square root 6, then the side measures 2 square root 6. Okay, so that's your answer. It's a lot of work for one answer, I know. All right, and that should get you through all 12 problems. You can watch these videos over and over again, despite my bad drawing and bad camera skills. And let me know if you have any other questions.